Imagine you're standing on perfectly normal ground when suddenly it starts to wobble, crack, and shift right under your feet. It feels exactly like a giant, invisible rubber band just snapped deep underground, sending a shockwave that makes the whole world shake. But think about it. The ground beneath us looks completely flat and solid. How can solid rock just decide to move? To figure that out, we have to zoom way out and look at the entire planet. To understand the source of that motion, we have to examine the Earth's outer shell, a dynamic, fragile system that is much more active than it appears. Earth's outer layer, called the crust, is not one single piece. It's actually broken up into about 15 giant interlocking rock shapes called tectonic plates. These massive tectonic plates are constantly sliding around, pushing and pulling against each other as they slowly restructure the globe. They move incredibly slowly, only about 1 to 5 inches a year. That is the exact same speed that your fingernails grow. Basically, the ground is just doing a very, very slow dance. I guess even millions of tons of rock need to take their time. But because these plates never stop drifting, they are absolutely bound to crash into one another. And when they do, things get messy. Take a look at this massive scar cutting right through the landscape. This is the San Andreas Fault, a physical crack in the ground where two moving plates meet and rub against each other. The edges of these rocky plates aren't smooth at all. They're incredibly rough and jagged. So instead of gliding past each other perfectly, they catch, scrape, and get completely stuck. Even though the front edges are stuck together, the rest of the plate keeps pushing from behind. All that pushing builds up an immense amount of pressure, stretching the rock tighter and tighter like a giant rubber band. So when a fault line looks totally quiet on the surface, it usually means an invisible, dangerous amount of energy is being stored up right below. Eventually, the pressure gets too high. Those jagged rock walls finally give way, snapping past each other in a sudden, explosive rush. All that stored up energy blasts outward, traveling through the rock as waves. When those waves reach the surface, they shake the ground, and that is an earthquake. The exact spot on the surface directly above that underground snap is called the epicenter. That's usually where the shaking is the absolute strongest. The violent shaking stops once the rock pieces snap into a new position, finally releasing that massive buildup of tension. Challenge time. Let's see what you remember about our moving planet. Question 1. Does the ground split open and swallow things up during a quake? Nope, that's just movie magic. The ground shakes side to side and up and down, but it stays solid. Question 2. Where do earthquakes happen? They occur all over the globe, but amazingly, they even happen on other planets. Check out this dome-shaped instrument sitting in the red dirt. NASA used this tool to officially detect Mars quakes happening right on the surface of Mars. That brings us to our final question. What specific tool do scientists use to measure the size of an earthquake's wiggles? This is a seismograph. It uses a pen to draw erratic lines on a spinning drum, and the bigger those wiggles get, the stronger the energy waves are. You completely aced that quiz. Smash the subscribe button to join the lab crew before our next science adventure. By tracking these vibrations, scientists can use these same seismic patterns to map the internal layers of planets throughout our solar system. Let's do a fast recap. Earth is made of moving tectonic plates. Where they meet are fault lines, and when they get stuck and snap, the released energy shakes the ground. Ask a grown-up if they've ever felt an earthquake. Then grab a rubber band, stretch it out, and show them exactly how pressure builds up before the big snap. Now you know how pressure builds up deep underground. But what happens when massive amounts of heat and pressure build up high in the ocean sky? Tap right here to dive into the wild science of hurricanes.